Hello friends, hope you are fine. In the previous section, we have already discussed about the relative velocity concept. What is the relative velocity concept we have already discussed about? One is VAB. What is VAB? Velocity of object A with respect to B, and we have discussed the VA minus VB. And other equation we have discussed here, VBA. What is VBA? The relative velocity of B with respect to A. So we have written that formula here, VB minus VA. So these are the formulas we have already discussed in the previous section, that is a relative velocity concept. The same concept now we are going to explain with the help of position time graph. So let's discuss about the relative velocity concept in terms of position time graph. So just before discussing that one, just imagine, okay, a one-dimensional motion. Just imagine the same object we are taking here, that is two cars, okay. We are taking two cars, the car A, and it is traveling along the road in a one-dimensional motion we are considering. So this is the second car, okay, the car B. Say the car A is traveling with a velocity VA and the other car is traveling with a velocity VB. So other terms you already know, that is XA of 0, XA of t, and XB of 0 and XB of t at the time t and when time is equal to 0, the positions. Okay, that's we have already discussed in the previous section. So first case we are going to deal here. So let's look at the first case here. What is the first case? When the velocities of both the object, in this example 2 cars, are same. So we can consider here the first case. So we can write here VA is equal to VB. VA is equal to VB. What is the meaning VA is equal to VB? Say an example, this object is traveling with 10 meter per second. This object is also traveling with 10 meter per second. So what will happen when they are traveling in the same direction, one-dimensional motion? The distance between these two cars will never change. It will go like this. Why? The displacement in between car A and car B will never change because they are going with the same velocity. They are moving with the same velocity. There we can write one thing here, that is XB of t, right, minus XA of t will be equal to XB of 0 minus XA of 0. That means the relative displacement between the two cars when the time is equal to 0 and when the time is equal to t are equal. So the displacement will be always equal because the VA and VB are equal. So in this case, what is the relative velocity VBA? VBA is equal to VB minus VA, right? Here VA and VB are equal. So what is the relative velocity VBA, which is equal to 0? Which is equal to 0. Now let's discuss how to represent this one in terms of position time graph. Okay. So let's draw the position time graph here. Along the x-axis it is the time, along the y-axis it is the position. We have taken the position as xb, xa, right? So we can draw the figure like this. The graph will be, the velocities are equal. So definitely, for this is the first one, say this as the xa of 0. So this is the another line, both are parallel to each other. So we can write it as XB of 0. Here what is XA of 0 and XB of 0? Position of these two cars or the two objects when the time is equal to 0. After some time what may happen there? If you take another time here, XB of t and XA of t will be, here we can see here both are equal. That means the distance between these two lines will never change. Both the lines are parallel to each other. The meaning is that the displacement between the A and B will never change because the velocities are equal. So this is the way to represent what? Position time graph for the two objects which are traveling in the same direction with the same velocity. So first case we have already discussed about. VB and VA are equal. So the relative separation between these two objects will be always constant. Correct? Now let's discuss about the second case. VB greater than VA. Here what is the second case? Velocity of object B is greater than velocity of object A. You just imagine. This is a one car and this is another car A. Both are moving on a highway. First of all, it is having a velocity VA and this is also having a velocity VB. Maybe they are equal. After some time, you just imagine the driver in the car B applies the accelerator more. Okay, what will happen to this car now? Car will go with very high speed, that is VB is greater than VA. What will happen to the relative separation between these two cars? This is also in motion, this is also in motion, but this speed is much more. So you can see here, practically speaking, the distance between these two cars will now increases while it is traveling, because the velocity of B is greater than the velocity of A. So the relative separation increases. So what we can write here? We can write here XB of t minus XA of t is increases. XB of t minus XA of t increases. That means the relative separation between these two objects will increases by an amount what? VB minus VA in each second. VB minus VA in each second. So how to represent that position time graph? This is a way to represent. See this one once again. X-axis it is a time in second. Y-axis it is a position in meter. SI unit is meter. If you draw the position time graph for, this is the object A. Okay, the object A, can write here XA of 0. This is the initial position of the object A when the time is equal to what? 0. Now we are considering another point, that is XB of 0. That is the initial position of the car B when the time is equal to 0. Now after some time what may happen? The relative separation is increases. So you can draw the graph here, the graph like this. You see what is happening here? Which one is more steeper from A, and this is a graph for B. This is more steeper. And as you already know, slope of the position time graph is equal to what? Velocity. So here slope is more, so velocity is increases. Now you can see here the relative separation increases. You see this one? The relative separation increases. So same, practically you speaking, the distance between these two cars will now increases because the car speed B is more. Okay, so this is the way to represent the position time graph when VB is greater than VA. Here XB of t minus XA of t, that is the relative displacement, increases by an amount of VB minus VA in each second or in each time. Okay, now let's discuss about the third case. Just imagine the third case, VA greater than VB. That's what we are going to discuss now. Now look at the third case here. What is the third case we have already discussed here? That is VA is greater than VB. That means the velocity of the car A is greater than the velocity of car B. So what will happen when the car speed is more? The car A speed is more. Just imagine. Both the cars are now traveling with a particular velocity. Now the driver in the car A just apply the accelerator much more. What may happen to the speed of the car A will increase comparatively car B. Both are in motion. So you can see here in practically, car A will now approaches to the car B, right? All are in motion, but the car A speed is more. So both the cars will approach for some time, right? After some time, while it is approaching, after some time, both the cars will come in straight or maybe in the same line. Okay, it's not going to hit here, but both are will come in a same meeting point. There will be a meeting point will be there. So when this car speed increases, after some time, both the car will come in one point. So we are not going to discuss about the collision. It will come maybe in a highway, two line. Okay, so both will come in the same line. Once again, you imagine the car A speed is more, right? Once again, after meeting that point, what will happen to the car A once again? The car A will move ahead than car B. Then what will happen to the relative separation? Relative separation increases because the car A speed is much more. So once again, let me tell you here, first case, the car A speed is more. So first case, it will approaches, the relative separation decreases. And at one particular point, it will meet. And after some time, the relative separation increases. So how to draw the position time graph for this case, VA greater than VB? So let's draw the x-axis, y-axis. Along the x-axis it is a time, along the y-axis it is a position in meter. If I draw the position time graph for the object A like this, you see this one, this is the object A and this is the XA of 0, initial position of the car A when time is equal to 0. Now as you already know, the slope of the position time graph is equal to what? Shows the velocity. So this one slope represents VA. Now the car B is the, just imagine this is the initial position of the car B, XB of 0. Here it is mentioned here VA is greater than VB. So definitely which slope will be more? The car A slope will be more than the car B. So I can draw here the graph like this. You see the graph here. Which one is slope is more for the car A? So this is the line represent for car B. Slope of the car B is small. Why? Because the velocity of object B or the car B is small. Now look at the graph here. Okay. First case, you see the relative separation decreases. The relative separation decreases. And at one point, both the car will come in the same line. It's not colliding, okay? It's come in the same line. After that, car A speed is more. So what will happen? The relative separation increases. So this is the concept. So first case, what is happening here? In this case, what we can write here? XB of t minus XA of t is now positive. It is a positive value. What is meant by positive value? Because this in this case XB minus XA become positive and it is now the relative separation is now decreasing. At one particular point, you see at this particular time, what will happen to the XB of t and XA of t? Become equal. At this point, XB of t is equal to XA of t. Now after this one, you can see the relative separation is increases. That means the car A is now chasing the car B and moving ahead than the car B, right? So the relative separation is increases. In this case, we can write here XB of t minus XA of t become negative. Here it is negative and here it is become what? Positive. So negative positive in the sense means what? Here the relative separation is decreases and come to 0. That means they are meeting at one point. And after that, what will happen here? Relative separation increases. So this is the third case, that is VA is greater than VB. VA greater than VB. Now you just imagine the same concept, but the car A and car B are traveling in opposite direction. So both the cars are traveling in opposite direction. Just imagine the car A is traveling in this direction and the car B is traveling in opposite direction. Okay, car A towards this direction and car B in opposite direction with the velocity VA and VB. So how to represent the position time graph for this case, right? If once again drawing here time along the x-axis, position in meter along y-axis. If I draw the car A is traveling in this direction, say it as positive direction, right? So I can draw, this is the graph for A, and here once again XA of 0 initial position, and definitely XA of t will be there after some time. Now what is the direction of car B? Car B direction is towards negative side, right? So we can draw the position time graph for the car B in opposite direction. Car B in opposite direction. See this one. What is the slope here? Slope here become negative. What is the meaning here? One car is traveling in this direction and a car B is traveling in what? Opposite direction. Okay. Now this line may come to the fourth quadrant also if the car B is now crossing the origin. Okay. So that's other case here. So this is the fourth case when two cars are traveling in opposite direction, the graph become like this. So just imagine practically two cars are coming closer, you see. So what will happen? The relative separation decreases. See this one, relative separation decreases, and at one point it will meet. So you can see here both are relative separation is equal to 0, and after that once again what will happen? The relative separation is increases. So this is the fourth case related to what? Relative velocity, and we have discussed the four cases for which one? The relative velocity, and we are explained with the help of what? Position time graph. So I hope you understand this all the four cases. Now let's discuss about a formula for the relative velocity concept. So the magnitude of relative velocity can be calculated using the formula. We can write the general formula like this. VAB is equal to square root of VA square plus VB square minus 2VA VB cos theta. Okay. This formula will be using when both the velocities making an angle. So for example, when the cars are traveling in different direction or maybe making an angle with each other, in that case, the velocity vector, if you are considering, the angle will be there. So this theta represents what? The angle between VA and VB. So this equation will be discussing later in the vector analysis section. How to derive it later we will discuss. Now you just learn about this is the general equation to calculate the or to find the magnitude of relative velocity. Theta is what? Angle between the velocity vectors. So for a simple example, if here VA represents in this direction, right? So what is a velocity vector direction? Towards this direction. VB represents the same direction, right? So you can see here that direction. So theta will be what? 0. So let's discuss about the two cases. That is case 1. VA and VB both are in the same direction. That means two cars are traveling in the same direction. So velocity vector will be in the same direction. So what is the angle between the VA and VB? That is theta is equal to 0 degree. Correct? No? Right. So what is the equation become? VAB is equal to square root of VA square plus VB square minus 2VA-VB. 2VA-VB because cos 0 equal to what? 1. This can be written as VAB is equal to, right, square root of, what is this one? A square plus B square minus 2AB. That is equal to VA minus VB whole square. VAB is equal to A minus B whole square here. That is equal to, can take the A minus B. So we can, what is equation become? VA minus VB. VA minus VB. So that means when both the cars are traveling in the same direction, you have to subtract the velocities if you want to find the magnitude. Now you just imagine the case 2. Just imagine the case 2. The two cars are traveling in opposite direction. Okay, when you are traveling in one bus, another bus is traveling, there is your friend is there in that bus. When both are crossing each other, what is the relative velocity? That's the question is asking here. So in that case, the theta is equal to 180 degree. The velocity angle become what? 180 degree. So what is equation become? VAB is equal to root of VA square plus VB square minus 2VA-VB cos 180. Cos 180 is equal to what? Minus 1. So what is equation become? VAB is equal to square root of VA square plus VB square plus 2VA-VB. This is equal to A square plus B square plus 2AB. That is equal to A plus B whole square. So what is the final equation become? VAB is equal to what? VA plus VB. So these formulas may be you required while you are doing the numericals to calculate the relative velocity magnitude. Okay. So the direction we are not mentioning here, that will be discussed in the next chapter in the vector analysis, and there also we will discuss how to derive this type of formula. I hope you understood this topic. Okay. Thank you all of you.